Hi everybody, my name is Roham. You might know me already. That's maybe why you're connected with me on LinkedIn, or I don't know, for some other reason. So I've decided to start this series on large language models and their use in AI for SC. Not that I'm an expert by any measure in this area, but I've been reading some papers here and there, and I would have appreciated like a very, I don't know, casual series on this topic when I was starting to get into it. So I thought I'd just like go over some topics. It's gonna be like a 30-day series, very casual, me sitting here, just some notes I make every day coming back from work. And yeah, just trying to give you an understanding of what LLMs are and how they're being used in software engineering nowadays. So yeah, we're gonna build up from the foundations and get to some more recent topics in terms of multi-agent systems, for example. And yeah, we'll go from there. Who knows, maybe we do a whole video series on this. So it's just gonna be every single day I'm gonna release a video like this. I'll try to make it every single day. Might take a day or two off here and there. And yeah, with every single video, I'll have 5 resources that will help you get the idea better, essentially, understand the idea. So 2 academic papers, 2 blog posts, and 1 video, and that's the format I'm going for. And I hope it's beneficial for at least somebody out there. Okay, so let's get started. So as I said, the idea is to talk about large language models, and I'll be using LLMs interchangeably. So LLM is a language model and a large language model is an LLM. And today I'm going to talk about where we came from, where we're now, and just essentially set the stage. So at their core, when we're thinking about this, these language models are designed to predict text. And a word that's commonly used in the literature is a token, which is not necessarily a word, is not necessarily a character. It can be a varying length of character sequences. So, for example, let's say my name is Roham, right? It could be tokenized. So when a text is split into tokens, it's called tokenization. When my name is tokenized, it can become Ro as one part and Ham as the other part. Or if my name is very common in the tokenizer's training vocab, essentially training data set, it's going to be one token. Roham is going to be one token. So here we have the concept that a token is dependent on data. We'll get back to this, but early transformers used to be based on, early models, language models used to be based on n-grams, which are statistics of sequences of words or characters which were observed in text. For example, when we have the sequence, the dog was sitting on the, then by some n-gram statistics, you would have a probability distribution over the words that could be possible, and then you would just sample the most likely word. And this was essentially how they worked. They were very reliant on the training data, and they kind of sort of worked. And then people got kind of tired of them and then moved away from them. So then came the era of neural networks, embeddings, recurrent models, attentions. These are all buzzwords now, but we'll get back to what these are in the following days. But the main thing that essentially shifted this whole landscape of language modeling was the transformer architecture, which allowed us to capture long-range dependencies and scale essentially much more efficiently. So what distinguishes an LLM from all the predecessors? So an LLM is a model that is pre-trained on a massive massive text corpora, in the order of like tens of trillions of tokens, or words, however you want to call it. And it's done so using a self-supervised learning method. And the idea is essentially to train a model to predict the next missing token. The hypothesis here is that by doing so with this training objective, the model will learn the grammar, semantics, facts, and then patterns about the language. And when you ask it to do a specific task, it would be able to infer what it has to do based on the context that it has in the text preceding the token it has to generate. And like the two resources that I've included, the academic sources, are really important to give you an idea of how this works. Another aspect of large language models that's really important is scale. Scale really matters when it comes to these models. Model size, training data, compute, all of these tend to have like very significant impact on the performance of these models. So a large enough scale, you get these emergent behaviors. So these models can start to follow instructions, to reason, generalize from a few examples, which is called few-shot learning. And these emergent behaviors are what sparked essentially this AI boom that we're currently in. And a very, I think, critical and like important example from this of this would be the GPT-3 paper, which is one of the resources for this post. I think the paper's name was Large Language Models Are Few-Shot Learners by Brown et al. And this was the model that came before the GPT 3.5 that was in the initial ChatGPT, which like took over the whole world, one of the fastest growing applications all time, I think even the fastest. And it had 175 billion parameters, which by modern standards for like commercial grade LLMs is practically nothing. The cool thing about this model was, instead of being fine-tuned on specific tasks, it was given a few examples about a specific task it was doing. So instead of being one shot or zero shot, which means given only one example or zero examples, one shot, one example, zero shot, zero examples. When you gave it a few examples, so few shot, it was able to infer how to do it. It was able to infer patterns from these, from the examples, and actually perform the task. So scaling up enabled the model to actually infer structure from these examples, which was really neat at the time. I gave you like a couple of ideas about how these models work, but in our current landscape, why are they important? Why are LLMs important? Why should we even learn about them? Because nowadays, essentially, LLMs are everywhere. We're interacting with LLMs whether we like it or not. So it's better that we actually understand how they work. I mean, you can start to live in your bubble where LLMs do not exist. You do not interact with AI. The sooner or later, like, you are going to interact with this. So it's better to know how it works. And there are a bunch of challenges. So if you're interested in research, there's a bunch of topics that are still unsolved about bias, about factuality, about safety, about data contamination, about resource consumption in terms of compute, data, energy, all this sort of stuff, which is also pointed out in the resources that I've included in the post. So it's really important to be able to be aware of these problems, to be aware of what solutions exist, to be able to actually move forward from what we have currently. So on a high level, today I talked about what LLMs are, what they mean for us, and kind of gave you a couple of historic examples of how it's been until now. We're going to build this up. We're going to build up to something great, hopefully. If you enjoyed this video and you think this series is going to be helpful to you, to anybody else, please like, share, repost. I don't know. I'm kind of more used to YouTube videos, so this is a new medium for me. But I think the entire interaction paradigm still stays the same. So thank you for your support, and until the next video, thank you.